Okay, then yeah, I explained enough about this different classes and so on, but we want to do something. So, and I think we just first of all we just try to compile this. I don't know if you schon yet compiled this code as a CPU. Then you can try simple start this application. So, and we need to go to our build folder bin. So where we have our application, but before we need to, or I have this. Yeah, you need to create here in build bin. Please create this output folder as a simple here bin, right mouse click and new folder. Okay, and input folder is an input folder as the two folders. So because yeah, we want to work with this.
Where is this?
Again, as your build, as in your case, build folder and the root, and then bin. I create this build, I call it this build VSL because I have two builds, one build for Visual Studio and second for Visual Studio Code, for container version. And I'm working now in my container folder. And here we have bin folder, and you create this input and output folders. And in input, you can put this two stale files which we download in previous session. Okay, so and we need this. Yeah, in config file we can see we have this path to output. Yeah, point slash output. It means the program will look in your bin. Yeah, because we started from bin, and in bin folder look in this output folder. Okay, and I think I know now why we have this arrow here. Yeah, so just me look again. So if we look in this pvd file, yeah, what we see again the same thing. This call it a relative path. Okay, if I think I is right. Yeah, relative path. And as you can see, PowerView cannot handle this. Yeah, because if you open directly this bin file, so yeah, it works. Yeah, the problem is this collection file with relative path. So you see, if we switch to the, yeah, you see this block grid was generated. So okay, then please, if you open this block grid, please open this directly bin VTU file, not the collected, because we have this problem with relative path. Okay, then we simple start. The point we need laminar plane flow. So, and then config file. A config file is an apps CPU. This we can simple right mouse click and copy path, and then here yeah, also in
In absolute path.
in absolute path, yeah, input here in absolute path. So enter and just run this application. And okay, we have, I think we have 100 1 million time steps. We want to wait so long. We can stop at this with Control C. So, and we're looking again in our folder. Or we can look here. Just a moment. Is bin output. So you have to see in output this laminar plane folder and some subfolders. Yeah. Again, as a BC is for boundary conditions, blocks for blocks, grid, block grid, geo for geometry files. This is, I will explain later, is our checkpoints and MQ microscopic quantities. So, and we can, so if you reload, okay, take time, you can see, as if you open in the pair view, the block grid, you can see the uniform block grid. Yeah, it's only how we expected this is 4 blocks in X and Y direction, and yeah, 1 block in the Z direction. So, and we can also open this MQ, and okay, I try this collection. Okay, does work. Let me check. Okay, yeah, you can see, okay, this has a little bit different format with this path, yeah, different handled with path, and then it's work because it's not has this
the relative path was wrong.
Yeah.
It was actually wrong because it was in the same folder.
Yes, it's okay. I need to check this, but okay, you know, you open simple direct this file. Okay, yeah, we can visualize, for example, Vx direction, velocity. So, and yeah, this typical channel flow behavior, and we can look. So okay, yeah, it's what with what was expected from this yeah application, so for Zollflow. So then okay, let me see in our plan. Okay, and the next step, as the next exercise will be we want to, now we have 2 boundary conditions, the same boundary conditions in inflow and outflow. Okay, this pressure boundary condition, but we want to have something like inflow velocity boundary condition and outflow pressure. So, and then we need to change, yeah, the first boundary condition. And we look in the code in our CPP file. Then is this yes, this place, yeah, first what we need to change, we define this pressure non-equilibrium, this pressure BC. So then we need to change this, Yeah. Okay, and here example how you can change this. So how you can create new boundary conditions or yeah, another boundary conditions. And I think yeah, in principle is everything what we talked about in previous session. Yeah, you need to create new BC object with this velocity BC, and this first three parameters is you say which in which direction you has velocity. Yeah, in our case in x direction, then it's true. And this is variable is defined so-called move parser. As a move parser is library, is third-part library. If we look, open this link in the browser. Yeah, this web space of this library. Yeah, you can read about this, but actually it's nothing to other is so implement some interpretation. You can write in mathematical expression, and this will be yeah, converted in C++ code, something like that. Yeah, and interpreted then automatically in your program. So we can say. So, and we use this to define some expression. For in our case, we need to define inflow profile. Okay. Do you have a question? No. Okay. We need to define. We want to have parabolic profile, in our channel. Yeah, because we want to simulate some flow over some object. Yeah, and nice to have the parabolic profile. So, and here is the formula for parabolic profile, and here is this example code how you can define this. And please, your turn, try to change the boundary condition from pressure boundary condition to this velocity boundary condition. Okay?
Okay, now working time.
Yeah, now working time.
So then it's time for us to help. Everybody
Of course, if you have some questions, welcome.
Everybody understood what
Again, I show you this. Yeah, you have this line 86, 80, 89. Yeah, and you can simple comment this with Control Sharp and try to. Okay, I open again the code. Yeah, try to implement this part. But what about you need to think? So put here the expression for parabolic profile. Yeah. Okay, I need maybe some additional explanation. Add some additional explanation about this move parser. Yeah. Yeah. You can use this expression, yeah, and it's simple. You write something like here, so mathematical expression, and here are these coordinates, yeah, y and z, y and z. The coordinates predefined always in VirtualFluids. And they are called xy, x1, x2, x3. Okay.
Lower.
So new person knows what X, Y, and Z are.
Yes. and this always predefine it. Yeah, you should instead xy that use this x1, x2, x3. Okay, and here in this line you can see how you can define, for example, u, yeah, some constants. In our cases, velocity, for example, yeah, this is inflow velocity. So, and you need to define this second constant h. Yeah, it's what means high of your channel. Yeah.
And a question: the syntax is, because this, like, we have power of 4. So the syntax is the same as.
Yes. Okay. No. We can look in the again on this side. Yeah. If you have some problem as of for the future, yeah, if you want to create your own expression for the boundary condition, yeah, you have always this help. You have this move parser site, and you can look here features and here, for example, binary operators. Yeah, and you can see which operators, how you can write which operators in move parser. Yeah, for example, power off. You need this. I don't know how it's called, sign, and other things. Yeah, you can see it's more or less similar to what we have in C++, but something we don't have in C++. Yeah, for example, power off. Then we need to use this, and you see priority. Yeah, and yeah, additional. The move parser has also built-in function. Yeah, you can see different cosinus, for example, sinus, and so on, logarithm. It's very helpful, very useful thing.
Okay, so now I think you have to go back to
Okay, just 1 minute attention, please. Okay, if you put your new boundary conditions in these lines, yeah, and you try to compile, then you have some errors. It it's find not the code, or the compiler don't know what is pressure BC is, and it is in line here 201, yeah, also where we define interactor for this boundary condition. Yeah, I told you we need interactor to discretize it, to set this boundary condition and so on. And in this line you see inflow, we define this interactor, and here is pressure BC1. You see is underscored. Yeah, here compiler don't know what is it. So then we need, so we need to change this to this other object, yeah, for other boundary conditions. So here you see this is parameter boundary conditions. So, and we define new BC, and we need to change here to new BC. Okay. Okay, who always struggled with this thing? Can you show the solution in principle? Here, interactor has two parameters. Yeah, as an interactor combines these things together. Yeah, you see, interactor has geometry for your boundary condition, and which boundary condition you want to apply to this geometry. Yeah, and so both this, you discretize your grid. Yeah, and set then boundary conditions. Okay.
But the other boundary, the outflow boundary, leave it as it is for now.
Outflow stays the same. Yeah. because we want to have on other side the same, yeah, pressure, also pressure. Okay. Okay, I symbol defines this directly in code. Yeah, I define this velocity, inflow velocity, and high our channel. So, and again, I need to change this interactor. Of velocity BC. So, and so yes, I need to recompile, of course. So I recompile again. Okay, it's compiled. I start again. Okay, if you open this in your in ParaView, you should see something like this. So, and yeah, what you observe here is some waves, pressure waves, but in after several time steps should be comes to stable steady state. So, and you can do another thing for as of this. Yeah, apply this line plot to y direction. So, and you can see it's actually parabolic. So yeah, you see it's became, yeah, yeah, it's become parabolic. So I need to reload again, but you see it's each time is more parabolic. Yeah, so so this result should be also as you have. Okay.
Did you get the same maximum velocity?
So there was a question.
Yes, which question?
We want to maybe to explain why whenever there is a refinement we get this shift, you know, in Q.
Maybe we'll discuss this when we do the refinement.
Yes, yes. As now we are working without refinement. Ah, okay, yeah, okay, yeah. But as I said, first we do this without refinement, but it's another problem with refinement. Okay, but what you want to show you other thing how we can add some object in the channel. Yeah, now we have some channel flow, but we want simulate some flow over object. Yeah, for example, flow over cylinder. So, and okay, so you should have something like this. Okay. So this is result, and then next step, yeah, we want to generate a cylinder, and second case we want to read some from the cylinder from STL file. Okay, so please put this line in your code. As this line generate new cylinder. Yeah, the parameters, but you need of course define coordinates. Yeah, where you want to put your cylinder. Best case maybe is in the middle of the channel. So, and this is coordinates, yeah, you can see as coordinate one end, other end, and radius, yeah, as coordinates for one end of the cylinder, other end for radius, value of radius, okay?
So then this cylinder is not yet recognized as an object.
No. It's with this line you generate only this geometry. Yeah, this without interaction with the flow. For flow interaction, you need to create this interactor, but at first we need to create correct geometry. Okay. Try to, and you can use this. Write in the output file, yeah, like here in the line 116, for example, yeah, or 17. This thing to control, yeah. So here is again the geometry object, and here pass. You need to change only this part, yeah, with correct. So, and yeah, just copy this line after line where you created a cylinder, okay? Compile and run, and you can check in the power view if you correct define this cylinder.
But now you have to go back to the slide.
Yeah, okay. So sorry. And the same thing you can do for the VTK file, but you need to define. Okay, here this pass out is this is the line to output. Yeah, okay, this is not for STL. Sorry. Okay. This line to for output. Yeah. Okay. First we work with generated cylinder. Correct. First we work with generated cylinder. We just try if to run and look in power view if geometry is correct, if it is in the middle of the channel and in correct position. So if you compile and run, then you should have something like this, yeah, in power view, some cylinder in the middle. We are going to next step. Okay, this was correct result with generated cylinder. Now we are going to next step. We try to read this the same cylinder, not the same, but similar similar cylinder from the STL file. Okay. So, and for this purpose we use. Okay, we have two STL. We have downloaded these two STL files. Yeah. One for cylinder, and other one is this airfoil, yeah, NACA 0012. So, and one is difference. Okay, there's different shapes, of course, but other differences. One file is binary. It's written as binary file. If we look inside this, what is this? Where is this? Here. Inside this file, yeah, cylinder is, yeah, some we cannot read this, and another file is readable, the ASCII file. Okay, and we have in VirtualFluids. At first, we need to use other other geometry object, yeah, the special geometry object for STL geometry for meshes. Yeah, this I told you, GB 3-phase mesh 3D. And this class has special functions. One is read mesh from STL file binary, if you have binary STL file, and read mesh from STL file ASCII if you have ASCII STL file. Okay. You need to know which kind of STL file you have. Yeah, but I tell you, yeah, cylinder is binary and ASCII airfoil is ASCII. Okay, try now to implement these lines. Yeah, and you can of course repeat this with output file to check correct reading. Okay. This is your decision, but I will a simple copy, yeah, for all of this, yeah. Okay, in this function you have the second parameter, remove redundant nodes, as default is false, yeah, but as Boolean, and you can you need to define this, yeah, or simple write false here. And it's true, you can use true if you have some problem with STL file, and then you can try to repair this with this parameter. If you by reading the STL file you have some exceptions, you can use here to, maybe it's redundant nodes, yeah, then you can fix this if you put here true, okay, but with a simple or good STL file, you don't need this. Okay, you set this to false. Yeah, because it takes some time. Yeah, this need more computation then. So and try first this only this without this last two lines. Okay. Try this, implement, compile and run and look in ParaView. What happens? So I can also open.
Yeah, by the way, when you do the explanation in front of the microphone, they are recording.
Yeah. So if I open this file, where's my cylinder? Okay. So this is cylinder. So cylinder very small, and then I can apply this transform things, yeah. So and then we have here translate, rotate, and scale. Yeah. First of all, for example, we want to scale. We want to scale this. So, and you see, if you scale is move it also. Yeah. So, and we need. Yes, origin is so yeah, it's move it, and then we need to translate, and we need again, yeah. First of all, we need to know, okay, in this order we do this operation, and second, okay, we need to understand what happens, okay. The second opportunity, we can do this directly in code, yeah, and we have this scale and translate function in this three-phase mesh object. So we can apply directly here, okay. Also try this, simple to apply these two lines. And look what happens. It's the same like here.
You can write it out and then you have
Yeah, the same write out. Yeah, it's just you does this before. Yeah, you you have to apply the scale translate, of course, before you make an output. Yeah, or just foresee what happens then. Okay, if you apply this, it should be. Oh, sorry. You should be have. As like this. So, also, you should have in the middle, okay? Also, if you apply also for airflow, also for the cylinder and airflow, the scales thing. Okay? So, if you scale 10, 10, then you should have something like this for airfoil, yeah? Okay, but you can see it doesn't interact with fluid, yeah. It's only geometry, but to interact, we need interactor, okay. Then you just create some interactor. You can copy some interactor. Yeah, this again, it has no slip boundary conditions. Yeah, just copy some of interactor of walls and change the name. Simple. Yeah, and here the object. Okay. And of course put correct name for geometry object. Okay, and the rest is the same. Yeah. Okay, in interactor, this last parameter means solid. It means if we want to simulate something, flow over something. Yeah, we say okay, everything, all points inside our geometry objects are solid. Okay, but sometimes we want to simulate some tube, for example. Yeah, and we can choose use this cylinder geometry to create a tube. Okay, and we have then otherwise in other words, yeah, we have inside the tube flow fluid points and outside solids. And for this purpose, you can end this last parameter. If you go to definition here, no, it was not correct. So, where is this? So we have where's defined? Okay, it's called inverse solid. But where's definition? Here. Yeah, this constant we need write inverse solid. It means inside the geo object is fluid and outside is solid. Okay, if you want to simulate tube, for example, and flow inside something, yeah, inside geometry.
What is the difference between inverse solid and fluid?
Okay, the other parameters at the moment don't use it. This for future purpose. Okay. Yeah, they are you know.
We are praying for.
Yeah, predefined for future implementations. Yeah, at the moment we have only solid and inverse solid. What is relevant for actual implementation? Okay. So, and yeah, okay. Try to implement this interactor, new interactor, and last, if you want to see something in our simulation, last step, we need to add this interactor here to the interactor helper. Yeah, you see he has defined it in the line 227 interactor helper, and we need add new new line with the same syntax. It add our interactor to this helper. Okay.
What is the helper?
Yeah, helper help user to handle with these interactors. Okay. Yes, because it is not so trivial. Because interactor itself is some we can say class would need also some special operation in between to put this in simulation, we can say. Yeah, and we can of course do this manually direct in this script or our main file. Okay, but it will be always copy paste again some 10 or 20 lines maybe. Okay, and for this purpose I write this helper. You use simple this helper. The helper has only 3 functions: add, select blocks, and set BCs. Okay, so and you don't care about what happens then, but you can always do the same what does this helper. Okay, in special cases, if you need like in this airfoil with poor Australian age, yeah, it's not so standard order handling with this geometry and so on. Then you can manually arrange this interactor, create special interactors, add something, and so on. Yeah, but this for our or for most of standard cases, it's enough used to this interactor helper, I would say. Yeah, and you can see it's easy to add something in your simulation, new boundary condition or new object, geometry object. Yeah, you simple create new geometry, new interactor, and add this interactor to the helper. That's it. Okay. And you can also easy to control in your simulation. For example, if you comment some line where you add interactor, it means you exclude this, interactor in your simulation. Okay, you simple switch off. Yeah, for example, you don't want to have this object in your simulation. You comment this line. You need comment 10 lines. Yeah, this all definitions. You simple comment this line and interactor, and you don't have this object in your simulation. So, okay, again, try to compile this and see what happens. Actually, you should have some interaction, some flow over object in your simulation. If we use STL file, we need also to use special interactor for this 3-phase mesh. Yeah, if we look in the interactors folder, so let me here interactors. Yeah, you see we have this. I showed you also in the slides. Yeah, you can check this. So we have these 2 interactors. These 3 could 27 interactors. This is for generated geometry, and the 3 could 27 3-phase mesh interactors. This is for 3-phase mesh objects. Okay. Yes. Then please, where you create this interactor for STL for this 3-phase mesh objects, you have to use this interactor. Okay. So you see this macros, yeah, and you just import new macro and you open this file. Yeah, this in principle this Python script. Yeah, and then you have these two buttons. The one button reload all, this reload all your pipeline, and second one extend time series. Or if you have time series, then also apply add new time series if you produced. Okay, it's very helpful and accelerate a lot of your work with PowerView.